Have you ever done a science experiment and wondered what it'd be like if you did it big? I have. My name is Phil, and I take your everyday science experiments and do them big. This is Science Max, Experiments at Large. Science Max! We're flying again on Science Max.
Gliding squirrel.
Throwing things, spinning things, tumbling things, and maxing things out just a little too much.
Go, go, go! Go, go, wait.
Keeping things up in the air is what's on the runway for this episode of Science Max, Experiments at Large.
Well, hello there, Science Maximites. Today, we're going to be flying on Science Max Experiments at Large. Take a look at this. It's my paper airplane. Give her a bit of a throw and she flies amazing. Now, take a look at this. This one is lighter than air. It's a helium balloon, and guess what? It flies on its own. See you later. Well, just hold on a second there, friend. What's this whatchamacallit called? I'll tell you. It's called a hoop glider. Give it a toss and she flies really well. But today we're flying in a whole new way, Science Maximites. I know it sounds like we've covered all the bases for flying, but we haven't. Come on, follow me. Oh, didn't actually realize how much these goggles would fog up. Where was I? Oh, right, we're flying today on Science Max. Come on. Today, we're going to be building a tumblewing. That's a kind of paper airplane that flies on a cushion of air. This is a big mouth tumblewing. It doesn't look like much because, well, it's not. It's just two strips of paper taped at either end. But what you do is you throw it in the air and you walk along behind it with a hard surface like this, and that little scoop of air keeps it flying. And here's how you can make a tumblewing of your own. But first, a word about paper. Did you know that paper comes in different weights? The kind of paper you get from the printer is actually pretty heavy. The ideal paper to use for tumblewing making is from a phone book. You may not have a phone book at home. They're kind of rare right now, but its paper is very, very thin and the perfect for tumblewing flying. Now, if you don't have a phone book around, you can use newspaper. It works almost as well. What you do is you cut out some strips of paper, and you just need two, and you put them on top of each other, and then you offset them, which means you take the top one and you slide it over till there's about maybe a centimeter, 2 centimeters, something like that. And then you take your handy dandy science tape, which is the same as regular tape, except you use this tape only for science, and you tape the edges very carefully like that, and flip it over to the other side. Make a little tape on this side, just like that, and there you go. You have a big mouth tumblewing. Now you also want to tweak it just like you do with a paper airplane. You want to curl the paper a little bit, curl this side a little bit, and let's see how it flies. You'll know you have it right when it doesn't go to the left or right, but just opens up and tumbles straight down. Ah, not too bad. That one curved a little bit, so I'll have to tweak it a little more. Now, the other thing you're gonna need is a nice hard surface. The kind of signs that you get when there's an election are perfect. I happen to have a few of these sitting around, and they are made of something called corrugated plastic. They're very light, but they're also very hard. So you can use this, but you can also use cardboard if you don't have any of these around. So what you wanna do is get your tumblewing and your hard surface and flip it in the air, get it flying very nicely, and then walk behind it with your board, and a scoop of air will be behind it, and it will fly. But it may look easy when I do it, but that's because I've been practicing quite a bit. So here are some tips for tumblewing flying.
Tumblewing flying tips. When flying your tumblewing, you want to be indoors, away from any wind or other kinds of moving air. A long hallway or a big room is best so you don't run out of space. The angle you hold your board is important. Too much tilt or too little and it won't work. Keeping your tumblewing in the air is mostly about the speed that you walk. Too fast and the tumblewing will go over the top. Too slow and it'll fall. Finally, practice, practice, practice. Happy tumblewing flying!
Now I just need an expert to help me. Okay, let's see here. Lisa from Logis Academy. She'd be perfect. Okay. And Oh, wait, I need a lab coat. Oh, and Lisa needs a lab coat. There we go, Lisa's lab coat. Good, my lab coat. All right, my turn. Oh, my lab coat changed color again. I'll fix it later. Lisa's gonna be here any minute.
Oh,
Hey!
that was so fun!
Oh, did you like the portal?
I loved it, hi, Phil!
Lisa from Logic's Academy, I'm glad you're here. Your lab coat changed color as well, though. It's supposed to be yellow. I think we had a glitch.
I kind of like it though, blue.
No, but we gotta do yellow. Yellow is the Science Max lab coat color.
Okay.
So, we are here to talk about the tumblewing. I've got my big mouth tumblewing here.
I have
Got
mine
yours?
too, yeah.
Now, what are we wanna max it out, obviously. What else can we do?
Well, actually, there's a lot of different designs that we could try. This is a big mouth tumblewing. There's also tumblewings that are just a straight sort of single wing.
Oh.
And then there's some that are like an actual airplane or a glider.
Ooh, and we can max them all out.
Of course.
All right, let's get started.
Let's do it.
And we'll get the yellow lab coats.
And I really like the blue.
We gotta get the yellow. There, now we've got our yellow lab coats. I've got my big mouth tumblewing, and I got my board to push the air.
Oh, look at that! I voted for you.
You did?
I did.
Oh, you were the one. Okay, so let's talk about the science going on behind this air surfer.
Okay, so just like in an ocean, if you were surfing in an ocean, you'd be surfing on a wave of water. Right now, our tumblewing is surfing on a wave of air that you're creating with a board. And air and water are actually both fluids.
Oh, cool. So
They
we can.
behave the same way.
So it really is surfing.
It is surfing. And actually, sometimes we call those air surfers.
Cool. Well, why don't we have a surfing competition? Because I actually have here a Team Phil board and a Team Lisa board. Okay, so what do you want? You want to have a race?
Yeah, absolutely.
Okay, you want to take this one? This one flies really well.
Definitely.
I'll make a new one.
Okay.
Welcome to the Air Surfing World Finals, almost live from Science Max headquarters. I'm Jim and I'm joined by Chuck. Today it's Team Phil versus Team Lisa.
Team Lisa has a lot of heart, Jim.
But Team Phil is on his home turf. Let's see how they do. Round one is, of course, the tumblewing race.
And a great day for air surfing. The teams are ready, and there they go.
Ooh, Team Lisa looks like she had some trouble starting. Team Phil has already pulled ahead, but Team Lisa is off the marks now.
I think that beginning fumble might have cost her.
Let's see. Team Phil with a commanding lead, but Team Lisa's catching up. Oh, Team Phil loses his tumblewing at the last minute. A great dodge and a pass by Team Lisa. Can she hold it? And no!
Taking 10 steps back is the rule when you drop your tumblewing, Jim. It's anybody's game.
Looks like Team Lisa fumbles her start. Phil pulls ahead. Can he be caught?
Almost at the finish.
Yes. Team Phil with the win. What an upset.
All right, you had a lot of practice with that one.
Yeah, okay, so you got another design?
Yeah, let's try the single wing
New
one.
design.
Okay.
So at the end of the first round, we have Team Phil with 1 point, Team Lisa with 0.
But now we go to the second round where the design changes. We're now looking at a single wing design. It still tumbles like the big mouth tumblewing, but made from a single wing.
Does that make them harder or easier to fly, Chuck?
A bit harder. They're faster and more maneuverable.
If you wanted to, you could research tumblewing, and you would be able to find this design. And this is what these show you where to fold it.
Yes. So the dotted lines or the dashed lines are where you would fold, and the solid lines is where you would cut.
What's more, Team Lisa has more practice with this version.
And they're off. Oh, Team Phil with another early lead, but Team Lisa's catching up.
Phil doesn't have much practice with this version, and it's starting to show.
You're right, Phil fumbles.
No.
Oh, Phil fumbles, and Lisa passes him for the win. There we go. At the break, we're all tied up with Team Phil and Team Lisa with 1 point
Look
each.
how well mine's going. This is an ornithopter. It's a machine that flies by flapping its wings. When people were still trying to figure out how to get something to fly, they thought, copy a bird. A bird flaps its wings, and it flies, just like this. So, why don't we have airplanes that fly by flapping their wings? It turns out that flapping wings is actually complicated mechanically. First of all, you have to tilt the wing when you go up so it doesn't take as much air, and then turn it so you push more air on the downstroke. So flying like this would be kind of hard for an airplane and really hard to do on a large scale. So humans came up with this, our propeller. Our propeller catches the air, and if you spin it fast enough, it gives you lift. So if you orient it upwards like a helicopter, it will give you lift, or if you orient it this way, it will give you thrust, just like an airplane. So that begs the question, why don't birds and insects use propellers to fly? Turns out, though, that rotating a propeller is really hard to do with something that has muscles and tendons. So in the end, birds fly by flapping their wings, and humans first learned to fly by rotating a propeller. Science.
Lisa and I are air surfing. We've tried 2 different versions of tumble wings, but now Lisa has a new design, one that doesn't spin as it flies.
Okay, so what do you have now?
Oh, check this out, Phil. This is a mosquito glider.
All right, so it's like a paper airplane.
Yeah, but it's not made of paper. It's made of a light foam.
Ooh.
The mosquito gliders work the same way as the tumble wings, but because they're much larger, they're much harder to control.
I got it. Oh, no, 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 no. Oh, almost into the stuff. Not bad, though, right?
You got it.
This is very tiring.
This is really hard. It takes a lot of flying time to master.
We got the hang of it, but we quickly learned that you have to run a lot faster with the gliders. And we were soon out of breath.
Whoa, sorry. You gotta be in good shape for this.
Turns out a bigger glider is much harder to fly. So,
Ultra maxed out mosquito glider.
we made it even bigger. Why? Well, because it's Science Max.
Bigger board.
We needed a much larger board and tried first with 2 people.
Ready? Going.
And then with 1. And the most we were able to get it to fly was not a lot. Our conclusion?
Large airplanes just don't fly very well.
Well, homemade ones.
But we can try something else.
Okay,
Let's try something else.
let's try something else.
Today only, I got a super special on anything that can fly. Go on, pick something out. Oh, I hit the paper airplane. Oh, good choice. Good choice. But guess what? Paper airplanes don't fly. Full price. Yeah, I know, but before you start arguing with me, you need to know the difference between flying and gliding. A paper airplane does not fly, it glides. You need constant thrust in order to fly. If you do not have constant thrust, then you glide. Take this bird. This bird can fly because it flaps its wings. It has constant thrust. On sale. But this airplane cannot fly. You give it some initial thrust when you throw it, but after that, it can only glide. Full price. But look at this. It's an airplane powered by a propeller on an elastic. Now we're talking constant thrust. It can fly. On sale. But it can get confusing. I mean, look at this flying fish. Nope. Flying fish cannot fly. They can only glide. Full price. Look at this. It's a cute little flying squirrel. He climbs a tree, jumps off from a high branch, opens his legs, and there's a little flap of skin there that allows him to sail to another tree. Haha, flying squirrel. No, not flying, no constant thrust. Gliding squirrel. Full price. Okay, tell you what, you came all the way down here, I'll make you a deal. Check this out. Flying fish, now it has a propeller, it has constant thrust. It flies for real. And ditto, squirrel with a jet engine. And now you know the difference. Something that flies has to have constant thrust. Otherwise, you're just gliding. Squirrel away! I forgot to gas him up.
Look at those clouds. Aren't they nice? Did you know there are different names for clouds? Like those clouds right there? Those are cumulus clouds. They're the kinds that look like cotton balls, really fluffy and light. Well, they're not exactly fluffy and light. First of all, they're not fluffy, they're wet. It would be sort of like being a very dense fog, and it'd be very wet if you were in that cloud. And they're also not light. In fact, they're not light at all. That cloud right there weighs about 500,000 kilograms. That's the same as 100 elephants. 100 elephants just floating around in the sky? Come on, how does it do that?
It does that because it's so spread out. But water is very heavy. Interesting to think about. 100 elephants just floating around in the sky above our heads at all times. Almost makes you want to go inside.
Our air surfing tumblewings worked well, but our mosquito gliders were a bit too maxed out to fly really well.
Large airplanes just don't fly very well.
Well, homemade ones.
But maybe we should try maxing out the tumblewing just to see what happens. So we did!
Okay, Lisa, I'm gonna throw it, and then you're gonna push the sign.
What?
Go! Wait.
Oh, did it go? What happened?
It didn't, whoa, it didn't work.
We tried it, and and it turns out, yeah, it doesn't fly.
Go, 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 go! Go, go, wait.
But I mean, this is Science Max, so of course we had to at least try maxing it out.
Phil,
I don't know if this is working.
it's heavy.
It's very heavy. Okay, maybe we should go back to a slightly smaller version.
Sounds like a plan.
Okay.
High five?
High five. This is a boomerang. Boomerangs are from Australia, and the cool thing about boomerangs is when you throw them, they come back. With practice. That was close. When you throw them, they come back. And it comes back. Comes back. Come back. Come back. So, why does it come back?
Well, if you take a look, it's made of two wings, like airplane wings, but with one important difference. You see, a wing has a shape called an airfoil, and this gives lift. But check it out. The boomerang has one airfoil pointed this way and the other pointed the other way, which means if you spin it in the right direction, each wing will get lift as it rotates. But how does lift make it come back? Well, that's the trick. You see, you throw it sideways. The lift from the wings makes it go in a big circle and come back to you.
So when you throw a boomerang, this side starts to go this way and it gets a little bit of lift. Then this side gets a little bit more lift, and then this side gets lift, and each time it gets lift, it starts to turn just slightly. So as the boomerang spins, it describes a nice big arc in the sky and comes right back to you. Ha-ha! And that's how a boomerang works. Thanks, Phil. No problem, Phil. Hey, do you want to get lunch? Yeah, lunch sounds good. Okay, come on. Well, the Science Max headquarters has a nice cafeteria.
We've tried air surfers of all shapes and sizes. And what have we learned?
Maxing out an air surfer by making it bigger is really difficult.
Very difficult, yeah.
So what we've decided to do is go back to our original big mouth tumblewing and instead do it on a maxed out obstacle course!
Tumbling surfing round 3, the maxed out obstacle course. Let's take a look at the obstacles. The tree slalom, the podium ramp, the hanging hoop, ring walk, wall of boxes, ladder tunnel, side hoop, ball promenade, and the barrel run.
So here's how we play. I go through and then you follow me. And if you make it through an obstacle and your tumblewing's still in the air, you get a point. And at the end, we count how many points we have and we see who won.
And it looks like they're ready to start. Here we go!
Where are you, Team Lisa? Oh. Whoa, yeah. Whoa, no. Okay, what do I do with the boxes? What do I do with the boxes? Going through the boxes! Definitely didn't make that one. Recover! Ah! Oh. Okay, definitely lost a point there.
I'm almost there! Right behind you!
of barrels over, getting
I
through
get
the
an
finish
extra
line.
point for
And Team Lisa. Oh, yeah! Nicely done. High five.
Awesome.
See how the airflow from the board keeps the air surfer in the air? Well, the trick is to give it just the right amount of air to keep it in control. Not too fast and not too slow. That's the science to good tumblewing flying. So, with the points from the last round added up, Team Phil and Team Lisa are tied again!
You know what that means? Tiebreaker! Thanks very much for watching Science Max Experiments at Large Tumblewings. You want to go first
I
this
do.
time?
Let's do it.
Okay, you go first this time, and then I'll follow you. I think it's easier to go first. So, okay, ready?
Yeah.
Here, Mark, set, go. Sorry, that's very loud.
Yeah.
Whoa! I didn't see you there.
Look at this.
You'll know you've done it right if you... Fixed!